Hi, it's Professor Lucien. This is Lecture 5, recorded so you'd watch it before we get together for our Thursday. I guess that's called Lecture 5, but it's more a discussion. And I'd like to continue what we did last week, which was I'll pose a bunch of questions to you, then we'll discuss it. So this lecture is all about root cause analysis, and I've got a lot of information here, so I wanted to go over it to make sure you got it. So here's a link to the recording that we're doing right now. If you are going to come to class on Thursday, I need you to register because we have limited space in the room due to the pandemic. Here is just a title page. Here's the lecture we're about to go over. Please, please, please watch this, the ABCs of root cause analysis. It's a YouTube video. It's good. It's informative. I want you to watch this example of the 5 why technique, which is a very popular root cause analysis technique that a lot of people use, and it's under 2 minutes, and it's really good. It's based off of work done by the Geron Institute, if you remember our quality management lecture. And then if you want to see another example of how in-depth you can go in an accident investigation, the Chemical Safety Board video of the West Texas disaster is pretty good too. They break it down. I've got a link here to the American Society of Quality, their root cause analysis. You know, we talked about quality before. Now we're getting into some of their techniques and root cause analysis here. Please take a look at that page and just see what you can absorb. And then I've got some papers as well that I'll bring over to us. And I'll tell you what I really want you to get out of them. I chose them all for a specific reason, and what I want you to get out of is pretty basic. So the first one is Tomlinson paper. Most important here, I want you to look through it. Most important here are these 2 critical questions. If the identified root causes are corrected, can this incident happen again? It's a question you can ask yourself either while you're doing the investigation or as you're wrapping it up. If you can't answer it, then you got more work to do. The second question is, will the countermeasures developed to correct the root causes really correct them? So those are the 2 sort of defining questions as far as how successful your root cause analysis approach is and whether you need to keep going. The next is a root cause analysis for beginners. Just look this, again, this is from a quality perspective. Take a look at this one. Just get some of the main points they have here, okay, please? This is an example of a group that used this technique and the cost savings involved with it. It's Boeing. Didn't mean to, break the surprise. And then, since we're going to be talking about injury ratios, sort of accident theory, I wanted you to read this paper by Fred Manuel. It's a name that you should be familiar with. He wrote a book called On the Practice of Safety. I think it's right over my shoulder. It's green, if you're going to look. But he critiques Heinrich. And this is something we're going to talk about more, especially when we get to the quote-unquote DICE lab, the sort of the randomization of injury outcomes. So please take a look at this. He makes 2 definitive points against Heinrich's work, and this is something we will discuss in class or during that session. I shouldn't say in class anymore because we broadcast live, but we'll definitely be talking about this one. So please take a look at that as well. So that's really everything here. Then I've got an optional handout from OSHA. You don't have to read that. I think I've already assigned enough. So just give me a moment and I'll have to cue this up. Oh, there we go. Everything seems to be taking a little bit longer. I'm worried. Come on. And we're in business. Okay, here we go. Oops, now she's jumping around. So, like I mentioned before, we're going to talk about Heinrich. We're going to talk about Bird because he kind of replicated Heinrich's work in the 1970s and 80s. We'll get into what root cause analysis is, the foundations of it. Even though we're going to be talking about human error later, I want to refer to it from a quality management perspective and then get into some other... we're not going to be able to do the in-class exercise. I think we'll do it on Thursday, but I just want to kind of just basically just introduce it to you. So these are just 4 of the theories that H.W. Heinrich wrote about back in the late 1920s, early 1930s. The first one is the domino theory. You see the dominoes, and it's not practical, it's not pragmatic, because rarely would the things that lead up to an injury be linear and unilateral. where one domino has to hit the other, but he is kind of the first person to introduce a work systems approach to safety. And so let's recognize him for that. Below that, he reviewed some, I think it was like 15 or 25,000 injury reports and classified what the major causes were. And as you can see, he determined that 88% of the accidents were due to unsafe actions by the person or unsafe behavior. He found 10% were due to unsafe conditions. And then there was this 2% that was unpreventable. The thing is, and if you read his book, in the next few pages, he talks about how even though there were multiple factors causing it, he tended to lump them, force them into a single category. And the other thing is, back then they didn't know what attribution error was, which we'll talk about, or we already talked about in Lecture 4, in which we tend to blame the person most proximal to the accident. And because that wasn't a factor, we tend to blame, and we blamed a lot. With this particular chart or model here, this is what gave the behavioral-based safety psychologists back in the 80s and 90s ammunition to say, oh, we got to, fix the behaviors. Look, it causes 9 out of 10 accidents. But we don't agree with that. The next is the pyramid, top right. So for every 330 exposures, 300 result in no injury, so like near miss, 29 minor, and 1 major. So that's the ratio of the outcomes. And a lot of people complain against this. And I think when you read the manual paper, this is one of the things he criticizes. And I also think it's the 90-10 thing we just talked about. That the exposures, there are some exposures that result in severe injuries almost all the time. And I agree, sure, but if you read the book, if you read his book and turn the page and read the reason for this model, the reason for providing these ratios is to say that there is value and importance in focusing on just an exposure. Because if the 300 no injury accidents, the near misses, are not reported, we never even hear of them, we don't know about them, and we only hear of the 29 and the 1, first of all, the 1 is going to get the most amount of attention because that is a major injury, which is disabling injury or death. So we're going to try to prevent that. It's going to get all the attention, all the effort. The 29 may or may not get some attention, but at least OSHA requires we document them. So we're now predicating our safety efforts on 30 reported occurrences, yet we had 300 that went unreported. Not to say they're all aligned or they're all equal, but that's more information that would have helped us. The more information we have, because safety is a moving target, the more information we have, it puts us in a better position to really understand and maybe prioritize differently. And that's what I'm going to show you in the technique this semester, that we're going to use risk priority numbers, and frequency is an important consideration. Whereas in many of the things that we do now, the way we measure safety, we focus too much on the severity of the outcome. And exposure, let me give you an example. You climb a ladder to change a light bulb, let's say. You wobble and fall. Think of all the potential outcomes. You may just fall and look around like, oh, nobody saw it, good. I'm just going to go up there and get the job done, and nobody is the wiser. You could fall and kind of hurt yourself, but you don't report it. You go home and you're just in pain for a few days. You could fall and it could really hurt, and somebody saw you and said yeah, we better bring you to the clinic and have you checked out, but you might be okay. You may fall and break something, and now you got to go to the doctor and get treated, and you may have to actually stay home and recover. Or you could fall on your head and you could die. Or experience a severe spinal injury or brain injury. So you see, and it was all the same exposure. So let's count the exposures and what led to that exposure to understand what we can do from preventing the fall. Because the fall happened, but the outcome, we're putting more weight on the ones that are worse, yet it was an occurrence. Let's focus on the occurrence. I've spoken too much on this. I'll cover it. I think it's in Lecture 7. Then he talked about the hidden costs. I don't like this because this has actually been updated. It's the 4-to-1 rule. 1 to 4, I should say. For every $1 spent on direct cost for injuries, for accidents, there are $4 spent elsewhere indirectly. And that's been proven that's more one-to-one now because of the costs associated with workers' compensation. Along came Frank Bird, and he published with Germain and sort of updated the pyramid. And you can see it here on the screen that it's now for every 641 exposures, 600 are near miss, 30 are property damage, 10 are minor, 1 is major. It's the same basic concept as Heinrich, that there's value in frequency. There's value in the reporting and the investigation of occurrences that could lead to injury, and not making the outcome dictate whether it gets reported or investigated or considered. And this all leads us up to the root cause analysis. There are all kinds of methods on the board here, on the slide. And you should recognize these: factor tree analysis, fishbone diagram, change analysis. We all discussed all these things in 388. The 5 why is a very popular one. Pareto analysis, failure modes and effect. They're all here. You read them. An incident investigation should tell you what went wrong, and that's typically all OSHA asks us to do. But a root cause analysis is attempting to identify why it went wrong. Because if we understand the why and start digging towards it, we then apply those 2 questions from the Tomlinson paper, we can maybe actually prevent it from happening again. And that's the point of the root cause analysis. It gives us a better chance to really find out what contributed it, and if we can control those contributions. Because they're not readily evident. And sometimes they're complex, but if we can do a good job, we can actually prevent injuries. Versus not putting in the effort to study it, blaming the person, just putting them through training again, or punishing them. Did you fix anything? Can you really expect anything to change when you really haven't changed anything? You focused on the worker themselves, and we had talked about that before. I'm itching my nose again. I don't know if it's these lights or what. As you can see, there's some diagrams here, and you've probably already read the screen. But again, we're trying to find out what led to the occurrence. Even if it's a person's decision to do something that was unsafe, what allowed that to occur? Do you remember Plan, Do, Check, Act? That's a Deming product from the Quality Management lecture. Root cause analysis and continuous improvement are intertwined. I had mentioned a little bit ago about Heinrich's, 88% of accidents are caused by unsafe actions. And it goes back to this concept of attribution bias. With the fundamental attribution error, overestimating the impact of an individual, actor-observer bias, attributing one's own behavior to external factors, and then self-serving bias as well. All these things are built into our DNA or our cognition, and they're actually accepting only pieces of information in order to make things easier, is what it really does. And that's why we tend to blame workers for getting hurt, for doing something wrong. But they didn't do it on purpose. It was not intentional to hurt themselves or to hurt others. There was something in the work environment that led them to do that. Even if there was a rule, don't do it this way. But the situation guided it to be that way. Or they've done it that way many, many times before. The pyramid thing, so they had a contribution in the 300 where nobody was near miss or nobody got hurt. But then this one time they did, and then you're asking, well, why did this happen? Because this is the way it's been. It's the way they've been doing it. The supervisor didn't say anything. Other workers didn't say anything. You just happen to not see it. Now, do you see the importance of the near misses? This came up in the quality lecture. And this is a systems approach. So Heinrich had the domino theory. This is called the balance model, and I've kind of turned it on its side. Superficially, we as humans default to blaming the worker, the person most proximal to the accident. They made a choice and it resulted in injury. We have to fix them. But what I'm saying, root cause analysis will pull us away from blaming the worker and look upstream and try to find out what we can do to change within the work environment, within the organization, within the communication, repair relationships, whatever needs to be done that leads to the person not being either put in the position to make a decision that may result in them getting hurt, or being able to stop and avoid, or just completely eliminate it. That's ideal, of course, but sometimes that's difficult. Documentation is very important to root cause analysis, just as when we talked about when you go after a safety management system. You document what you do, and then you do what you document. That's right there on the top. It's really the same thing. Root cause analysis, continuous improvement, or quality management predicating continuous improvement is being more scientific, more objective. And the goal is to learn. And I talked about learning culture versus the old adage of safety culture, which I don't like. Isn't it interesting that these things we're talking about, they keep popping up? Quality management. You got these things. So if we were in class, I'd show this, but I'll have you watch it on your own. Here's the basis of a 5. Why analysis? It's not to say you stop at 5 or that you have to make it to 5. It's asking why multiple times to really understand. And I think in the ABCs of root cause analysis, they take you through like a scenario. Or you could see it in the Geron Institute video. Fishbone diagram, again, it's a different way to document, to guide you through questions or guide your investigation, at least to look away from the worker or not consider them right away into what actually led up to the accident. Here's just more mappings. You can purchase software that can guide you through root cause analysis. I know we were going to get one for free, but then you need scenarios to teach students to go through it. So wherever you go work, they should already have chosen whatever template or interface, whatever system they purchased. But if you need to, what would I recommend? Go to the American Society of Quality. They have all this stuff. I found all this stuff online, and you can get it too. This is an FMEA form. This is failure modes and effect analysis. This is a little bit simpler. It's very similar to a risk analysis, that you're assigning numbers you see on the screen for severity, occurrence, detection. You get an RPN, which is a risk priority number. It's just a product of multiplying severity times occurrence times detection. The higher the number, the greater the priority, essentially. And then some workplaces, what they do is once they put in corrective factors, they recalculate each of these numbers to see if it's gone down. And if you can see the example on the screen that the severity stayed at 8, the occurrence went from 4 to 1, the detection went from 4 to 3. So it went from 128 to 24. And sometimes what they do is they put in like a ceiling number. So as long as you're below that number, it's no longer a priority for the safety program at that point. This is a risk analysis matrix. Same sort of thing. You give it a severity rating, you give it a probability rating, and you figure out on the matrix here what you have to, what the outcome needs to be. It's meant just to disguise, it's meant to prioritize, to sort of triage and guide you on what needs to be done. This is a fault tree example. Fault tree analyses are typically made for engineers because they need a little assistance in understanding how people could get hurt or a failure could occur resulting in a disaster. And by mapping it, as you see on the tree, with Boolean operators, you can it helps you track back, peel back certain layers to figure out what could contribute. We are already on the review, so please read these. This PowerPoint is provided to you. As stated earlier and in the weekly reviews, this is where I usually draw my quiz questions from when I used to hold the questions in class, and this will come up in our gatherings on Thursdays just to make sure that you are reading certain things and catching certain things. But I kind of give you an overall. So in class, we're going to look at this stuff. We're not going to be able to get into groups. We'll kind of just talk about it as a group here. But what I did in the spring, this was their performance up until this point. And what I did is I showed them that there are correlations between certain Canvas performance that I'm monitoring and the quiz averages we had so far and their cumulative GPAs. I collect all that prior to every semester. I used to use it to guide me with assigned seating. And it's always a strong correlation. I always find that people who put in the work tend to get decent outcomes. And so the question that I posed to everybody was, what are you doing for the class? Is it working for you? Because I believe what I've learned, what I've seen, what in my many years, is that students with higher GPAs tend to have already developed what their learning technique is and have honed it over time. So they know how far in advance they need to start a project. They set time aside during the week to get things done. Some of them are procrastinators, and they've learned to be able to operate under pressure. That they're good at documentation and providing of details. When they go to lecture, they're taking notes, and they're thinking about it as they're taking notes, so it absorbs into their brain with different triggers for recall. They review their notes and either summarize them or combine concepts. When they prepare for, if there's an examination, they have a process they go by. But then we have other people who maybe don't have as high GPA, and they don't really understand their learning technique, what their strengths are. They show up to class because they feel they have to. They're distracted. They're not really taking notes. They tend to sit in the back of the room so they don't get called on. And then they just try to get by for when there's exams or when there's a project. They hope for some sort of divine intervention. It gets the last second, and they try to just get through it. I've seen the game too many times. And it's really too bad because it goes back to becoming responsible and taking ownership over your learning technique and having it work for you, and learn about it, continuously improve it, to appreciate and enjoy learning. That's really, once you get to that point where you really enjoy it, that you understand that this is going to contribute to my future career, this is how it affects my life, make the most of it. I like the Harry Potter novels, but I was really upset those first couple of years that he's at this awesome school to learn witchcraft and wizardry, and he's pissing his time away running around the castle and playing Quidditch. Dude, get in the library with Hermione Granger and learn the spells. That's what I would have been doing. Because if you really if you understand what a great gift, what a great advantage it is to love to learn and understand how it works for you and want to do better, school becomes very easy. And non-traditional students who go out and work and then come back, or serve in the military and come back, usually come in with that desire, that appreciation, and they don't have to put in as much effort. So if I'm speaking to you and you're relating to this, realize that this class, what I'm trying to do is really get you to focus on your learning technique. I am giving you the opportunity to do it. Handwritten notes, write summaries, summarize papers, how are you connecting to it, and then getting together. So it's not the accumulation of knowledge, it's the development of your learning style. And I had said that in lecture 1. I'm babbling, so I'm going to cut this off. I'm sorry it went so long. But if you ever need any help and want to talk about your learning or your frustration with classes or whatever it might be, trying to figure out how to connect what you're doing today to what you're going to be doing 3 years from now, please reach out to me. Send me an email. We can set up a WebEx or a call. I'm more than happy to help out anybody who really wants to elevate their learning technique or their love of learning. So, all right, hope to see you in class.